Alright, so we just finished up getting all of the Pythagorean identities, reciprocal identities, and the quotient identities. And so now I want to show you how to use these in problems that we're going to simplify. And so these problems are sometimes challenging just because there's no like set way, like do this first, do this second, do this third, and it works every time. Every single problem is different. And so there are different things you can try to see if they'll work. And some you'll be able to tell that you can use that method on, and some you won't be able to use certain methods on. But so these can kind of be challenging just because there's no one certain way to do it. But these are different things that you can try to simplify these expressions. So first thing you need to do is, if possible, you can try factoring out a GCF and see where that takes you. Then sometimes problems will be set up into a problem that looks like you could backwards FOIL or factor, if you could. Third, and this is what will work, like I would star this like a bunch of times, because that's what will work like 99% of the time. That's what I do, like when all else fails, write it in terms of sine and cosine. So try that if nothing else works. Fourth, if you have fractions, this is basically when you have fractions, okay? So if you don't have fractions, you can't really get a common denominator. So that's if you have fractions. And then fifth is don't leave fractions. So if you have a fraction as an answer, you can simplify that 99.9% of the time. And so you don't want to leave fractions, you want to simplify into another form using your identities. And then last, this sounds really dumb, but every time people try these problems, or I have students that try these problems, they just want to sit there and just look at the problem and not do anything. And so the main thing is to try something. Don't just sit and stare at it for 15 minutes, because then you've wasted 15 minutes. But try one of these methods. One of them more than likely will work. And so you need to make sure that you try something and don't just sit there and stare at the problem. And so I've got about 10 examples that I'm going to do for you. If you understand them, then you don't have to watch them all. But I'm going to do them because the more you practice these problems, the better you get at them. And the better you know your identities, the easier they become. And so I'm just going to do a lot of them in case you need the extra help. But if you don't, then you don't have to watch all of them. So that's just up to you. So here's my first problem. So I'm going to look back at my little steps that I have here that I'm going to try. So I'm going to look at this problem. Well, there are a couple things that I know probably are not going to work. Probably don't need to get a common denominator. There are no fractions. What looks obvious to me is there are two terms in this expression, and they both have a sign. So since they both have a sign, I'm going to factor out that sign as a GCF. Now, I'm left with sine and then my cosine squared minus 1. Now, anytime you see a trig function squared and a minus or a plus 1, you need to automatically think Pythagorean identity, because more than likely you can use a Pythagorean identity and just manipulate it some way to plug into what you're needing to simplify. So I'm going to look for a Pythagorean identity that has a cosine squared and a 1 in it. So let's go back over here. This is the identity that has the cosine squared and the 1 in it. So I'm going to copy and take this over here and show you how we're going to manipulate that and use it. So let's delete that. Now, any form of this identity will work. I can use it. So what I'm going to do is I need this identity to look like this. I need the cosine and the minus 1 to be on the same side. And so I need the cosine to be positive and the 1 to be negative. And so what I'm going to do is, in order to make that happen, have the cosine and the 1 on the same side, I would need to subtract this 1 to the other side and make this cosine squared minus 1. And then also take this sine and subtract it over here to this side. So this would be negative sine squared. And so this is just an alternate form of what this identity says originally. And these two are the same thing. Like, you can use them interchangeably. And so for all of those Pythagorean identities, you can move terms around and move them and use them how you need to. So since I know cosine squared minus 1 is the same thing as negative sine squared, I can take this negative sine squared and plug it in for that. And so then this is just going to be sine times a negative sine squared. And so then when I combine those or multiply them, this is just going to be a negative sine cubed theta. And you'll know that it's simplified whenever you get down to like one basic function. And so all of the problems that I give you are like one basic function. Now I'm going to do another one like this to hopefully make that a little more clear, because I know this is semi-confusing at first. Alright, so let's do one that's real similar. So this one's almost exactly like the last one. I've got two terms. Both have a cosine, so I'm going to factor the cosine out. And that will leave me with sine squared minus 1. Now, I'm going to go ahead and use this same identity that we had. And so this time I need it to look a little bit different. So I'm going to subtract the 1 over the same way that I did, sine squared theta minus 1. But then I would also need to subtract the cosine over to the other side to get it to look like I need it to. And I did that because I wanted this to match this identity, because that lets me know that I can plug in negative cosine squared for that. So then I'm going to have cosine, and then I'm plugging in negative cosine squared. And so when I combine those, that'll be negative cosine cubed. And that'll be my final answer. Alright. Number 3. This one's a little bit simpler than what we just did. So I'm looking at it. I can't really factor out a GCF. I can't really backwards FOIL. I can't really get a common denominator. And so basically the only thing left for me to do is to write this in terms of sine and cosine. And so I'm going to take tangent, and that is going to be sine over cosine, if I write it like that. And then this is going to be times. Cosine is already in terms of sine and cosine. So I'm just going to leave it. So this is like a cosine theta over 1. And now when you have this, the cosines are going to cancel, and that'll just leave you with sine. And so that one's definitely a little bit easier, I think, than the first two. Alright, let's look at number 4. Now, that looks pretty simple, but we said in our original list of things to do that you never want to leave a fraction, and so we've got a fraction, and I don't want to leave it. So, can't really get a common denominator because there's only one fraction. I can't factor out a GCF, I can't really backwards FOIL. Basically, the only thing left to do is write it in terms of sine and cosine, and so I'm going to do that. Secant is just 1 over cosine. Cosecant is just 1 over sine. And so I'm going to have to take this as a double-decker kind of fraction here, so I'm going to have to take the bottom and flip and multiply. So I'm going to have 1 over cosine times the bottom flips. So this is going to be sine over 1. And so in the top, I'm just going to have 1 times sine is sine. Cosine times 1 is just cosine. And then I'm not going to leave it like that because that's a fraction. I know that sine over cosine, though, is just the tangent. And so tangent would be my final simplified answer. Alright, number 5. Now, this one, I can't really get a common denominator now. The GCF, the sine, is already factored out. And with these, there's a couple of different ways you could go about doing this. I could go ahead and turn everything into terms of sine and cosine, and so that's typically what I do. There is a different way you could do this one. I'm just going to show you the shorter one. So if you were to stop the video and do this different than me, but you end up with the same answer, there are more than one way to do the problem. So I'm going to go ahead and say sine, and tangent I'm going to turn into sine over cosine, plus this is just going to be cosine over sine. And now that I turned them into sines and cosines, I do have two fractions that need to be added, and so I'm going to get a common denominator. And so this needs a sine and a sine. This needs a cosine and a cosine. And so then I'm just going to leave this sine alone right now that's in front. But across the top I have sine squared plus cosine squared all over. The bottom is just going to be a sine and a cosine. So sine cosine. Now, anytime, like I said, you see squareds that are added together, you need to automatically think Pythagorean identity. And that just so happens to be this same identity that we've been working with. So even though they're in a different order, 2 plus 3 is 5 and 3 plus 2 is 5, doesn't matter what order you add. So if I have sine squared plus cosine squared, it's the same thing as cosine squared plus sine squared, which is just 1. So then I'm going to replace that entire numerator with 1. And so then I have this. Now, this is like a sine over 1, so when I multiply right here, the sines are going to cancel out, and that's just going to leave me with 1 over cosine. And a lot of people will stop there and just leave it, because it's a whole lot simpler than what we started with. But you don't need to leave fractions in your problem. So I'm going to write this. I know 1 over cosine is just secant. And so I'm going to write that as secant. And that would be my final answer. Alright, number 6. This one is another one where you have two terms and they have a common factor. So I'm going to factor out a GCF here. So this is going to be cotangent squared and then 1 minus cosine squared. And so then my 1 minus cosine squared, we're still going to use this same identity. I automatically think Pythagorean. This one's a little bit easier than the first couple that we did, because in order to make our identity look like what we have, all I would need to do is subtract the cosine over. So this is just going to be sine squared equals 1 minus cosine squared. And so I'm going to plug this in for what we've got right there. And so that leaves me with cotangent squared times sine squared. Now, I can simplify this a little bit further, because cotangent squared, I can rewrite that in terms of sine and cosine. And so I'm going to go ahead, actually this one, I don't know if that would really get us anywhere. Oh yeah, so this is going to end up being cosine squared over sine squared times sine squared. And so then when I do that, that's like a sine squared over 1. My sine squares will cancel, and that'll just leave me with a cosine squared. And so that would be my final answer. Alright, number 7. This one looks like something we would try to factor out a GCF from, but there's not really anything that I can factor out. So I'm going to go ahead and turn everything into terms of sine and cosine. So sine is already a sine. I'm going to leave it. Cotangent is cosine over sine, and then I'm multiplying by cosine. So I'm going to go ahead and just combine those two terms right here. Okay, so this is going to be sine plus, this will end up giving me cosine squared over sine. Now, I've got two things. This is like, this sine has a 1 in the bottom of it. And so this gives me two things that I can get a common denominator with. And so I'm going to go ahead and get a common denominator. And so across the top, that's going to give me sine squared plus cosine squared over my common denominator, sine. Now, when I use my identity, so we're still using that same identity, I know that sine squared plus cosine squared is 1. So this is really just 1 over sine. And then I don't want to leave my fractions, so I know that 1 over sine is just one of those reciprocal identities, and that's just going to be cosecant as my final answer. Alright, we have 3 more examples, and I'm about out of time because my little screen cuts off after 15 minutes. So I am going to go ahead and make a third video. If you don't feel like you need to watch those examples, then that's fine. You don't have to. But the 3 that I'm going to do on the next video are some of the more complex ones, or the more challenging ones. So if you have trouble and you feel like you need to see some more examples, you can watch the third video.